Yes, sir. Good evening, sir.
Loud
Good
and clear. Good
evening.
evening, bro. Yeah.
Okay, thank you. So you are welcome to tonight's interaction. So for today, we want to discuss basic statistics for in research, in our research work. So what I'm going to try to do is to quickly highlight the role of statistics in research and provide some insight into some of the key aspects of the kind of basic statistics we require when we do our research. So I think the important thing about statistics is that it practically cuts across the entire research cycle, from planning and design through data collection, data analysis, and even the final interpretation and reporting of data. And that is why we always emphasize that it's important to involve a statistician from the beginning, because you can see immediately that if you get it wrong, if you get the statistics wrong from the planning stage, it means that by the time you get to interpret your data, you are still going to be coming up with wrong interpretation and wrong conclusions. And as we set up our research teams, it's important to, if you can, incorporate a statistician into your research team. If you cannot, and you are applying for a grant, then you must budget for involving a statistician from the beginning. Not because one of a common mistake that people make is when they do their research budgeting, they just budget and say payment to statistician, one-off data analysis. No, it has to be right from the beginning. So when a funder is looking at it and he sees that you don't have a statistician in your research team, and then you say you're only going to pay a statistician to analyze data, they will become very uncomfortable because they are not sure that the data you are going to be collecting, you'll be able to have it in a way that the statistician can actually analyze. So I think we'll take it right from the beginning of the research cycle, from planning and study design. The importance of statistics here is the fact that a lot of what you are going to do depend on the type of study. And if you are going to be calculating sample size, then you need to power your study properly. And the minimum acceptable power is 80. And that's what will give you the 95% confidence interval. And the higher the power of your study, then the more conclusive will be your findings. But if you power your study below 80, then it means that your p-value, you are going to be using something that is more than 0.05, and that level of statistical significance is not going to be very useful. So you need to decide from the beginning what power of study you are going to use. If you want to achieve, if you are going to use a p-value of 0.01, then you need a power of more than 90. So this is where the statistician will help you. And once you have the right power, you then be able to calculate a sample size. All this, you need the help of a statistician. It can be cumbersome trying to do some of this on your own, especially if you are doing a research that is not just a very simple kind of research. The kind of sampling technique you are going to choose will also depend on the type of study, because the main aim of the sampling technique is that you want to minimize bias. So all these have to be decided from the beginning. And the statistician, depending on if you are using a sampling technique or a kind of study design that requires some kind of correction factor, then the correction factor needs to be decided from the beginning. So again, these are all not things that you want to be struggling with on your own. Once you have a good statistician, they will help you to sort all this out. But just going back to the power, calculating sample size, confidence interval, p-value, correction factor, and all that, a lot of all these have been simplified by available statistics software. So if you are familiar with Stata, Stata will actually help you. All you need to do is to tell Stata what kind of, what level of p-value do you want to use as your level of significance. Once you put it in, and you put in the type of study you are going to be doing, it will tell you what the power should be, and it will tell you what the sample size should be. You just need to input the right. There's also another software we call GPower. GPower also helps you to calculate your sample size. Again, you can see all you see at the bottom here. Once you put in the right information, it will tell you the sample size. So really, you may not need to go through all those complex formulae that people use to calculate sample size. The available statistical softwares should help you to do that. Stata is very robust, and once you are familiar with it, it's very good to use. You can also use GPower. The thing with GPower is just designed entirely for calculating power and sample size, while Stata really is can do almost all you need to do in statistics. Then when you come to the data collection, it's so important that you collect your data in a way that can be retrieved and analyzed. So whenever you are designing your data collection method or platform, you need to have at the back of your mind, how am I going to analyze this data? Because if you don't collect the data properly, for instance, assuming you are trying to look at the role of duration of surgery on complications following cleft palate repair. If in collecting the data, you just put the exact time, maybe you put 1 hour, 2 hours, you are going to run into problems. What can happen is that those collecting the data for you may just be estimating. So in order to be accurate, what you need to do is to put the exact time surgery started, then exact time surgery ended. So it becomes easy for the statistical software or the statistician to quickly know what the duration is. So, and you need a statistician, because for most of us clinicians, we would prefer to just put the exact timing. Many times that is just an estimation. So those are the kind of things you need to have at the back of your mind. And the kind of data, are you going to be using paper to collect data? In these current times, using paper to collect data is really very cumbersome, because the problem with that is that you are then going to have to transfer that data to an electronic platform for analysis. And each time you need to transfer data from any point to another, there's always the risk of errors happening. For instance, somebody may see an 8 in the paper format and may misread it as 3, depending on how it is written. So it leaves room for too much error. So because of that, I think that as much as possible, we should use appropriate and friendly electronic platforms to collect our data. RateCap is very good to use. It's a free source platform. SurveyMonkey is also good to use, but the thing with SurveyMonkey is that if you are doing if you have many data points, then you need to subscribe. The free one really only allows a little. You can use Google Forms, but again, it also has their limitations. But all these data collection platforms have the capability of being migrated onto any statistical software, or just simply, you can simply download them as an Excel spreadsheet and then transfer them to a statistic software. So very importantly, as much as possible, we should use a friendly electronic platform for our data collection. And the statistician will tell you that, no, don't collect this data this way. It's so painful. Sometimes you spend so much time doing a research work, collecting data, then you finish and you give the data to a statistician and he tells you, I'm sorry, this data cannot be analyzed. That is because you have collected it in a way that is difficult to analyze, or he tells you, sorry, we need to do so much data cleanup that will be very expensive. The cost may even be more than the cost of data analysis, because maybe if the data was collected, maybe male and female, in some places it has been collected as capital M and capital F. In some places it has been collected as small m and small f. So it becomes difficult that the software is going to read them differently. So all that has to be cleaned up. But if you are using an electronic software, then it makes it a little bit easier to sort that out. Then coming to the main data analysis, I think what I want to emphasize here is the fact that once you've done your research work, at the time of data analysis, you should use appropriate statistics. If you are using a pure statistician, then you need to guide the statistician, because as far as the statistician is concerned, he's just going to put out any output. So you need to guide the person to let them know exactly what you want to compare. Otherwise, if you just throw the data into their hands, they will give you so much unnecessary statistics that even you yourself who did the research work may get confused. And remember that, and how you guide them is to focus them on your research questions and your hypothesis, because those are the things you want to address in the data analysis. And once the data is being analyzed, there are mainly two types of statistics or analysis that are important. There's what we call descriptive analysis and then inferential analysis. And I will say a little bit about each one of them. So for the descriptive statistics, all it does is that it just describes the characteristic of your data. And mainly all that you need there are univariate analysis. Every research work, the data analysis must start with descriptive statistics. You cannot just jump to begin making inferences without describing the kind of data that you have. And the univariate analysis, the kind of data points that we analyze here include measures of central tendency, such as mean, median, average, and mode. And then you may also want to know the spread of your data. And that's where the range, crude range, and interquartile range comes in, the standard deviation and dispersion. We will come back to them again down the line. So these are descriptive statistics that you need for every research work that you do. The data analysis must begin with description. So once you've done that, then you want to go to the main domain, which are the inferential statistics. And what this do is that it helps you to draw conclusions about a population using a sample. Remember that the research work that you did is based on a sample, and you are going to try to use that sample to draw conclusions about a larger population. So here you will now need a bivariate and sometimes multivariate analysis, depending on the kind of data points that you have. And this really, inferential statistics is applicable mostly to where you are trying to test a hypothesis. There are some research work that are not some study designs that may not be amenable to inferential statistics, or you may need, or you can do, may just be descriptive statistics. For instance, if you did a qualitative study, you don't have so much numerical data, then you are probably just going to be describing the population or the data that you have. So it's not all study designs that will be able to allow you to do inferential analysis. And there are the common inferential statistics that we use when you are trying to test associations and relationships. And we are all familiar with the t-test, the different types of t-tests, the chi-square tests. Now remember that each of these tests have their limitations, and they have different types. For instance, if you are dealing with categorical data and you want to use chi-square data, chi-square test, and your sample size is small, then you cannot just go and use the straightforward chi-square test. You may need to use different modifications, including the Fisher's exact test. So again, this is where the statistician comes in. The statistician we decide based on what you want. The statistician will be able to give you the kind of analysis that you want. Now, another type of inferential statistics that you may need are regression analysis. The main thing about regression is that it tries to estimate the effects of an exposure on outcome. And what that means is that it's trying to estimate the relationship between a dependent variable. For example, if you are looking at outcome, say fistula rate following cleft palate repair. So the fistula rate is dependent because it will depend on so many other factors. And you want to see whether age of the patient actually has any role to play there, and that age will become an independent variable. So, and because you have patients, you have age of patient, you have technique of surgery, you have level of whether it was a consultant or a senior registrar, you have so many other factors in order to then find out whether which one of the factors are really related to the fistula rate. You need a regression analysis. There are different types of regression analysis to do. It may just be simple if you are dealing with just one dependent and one independent variable. But if you are dealing with so many variables, then you may need to do a multiple linear regression analysis. If you have more complex data, you may need to do logistic regression. There are a number of other regression analyses that may be required. But again, the statistician will be in a position to help you once you tell the statistician what exactly you want to do. And when you report, especially when you send your manuscript for publication, if you indicate that if you use the wrong statistics, what journals do many times is that if they see a manuscript that has so much statistics, they will actually send it to a statistician to review, in addition to two other reviewers in that field, because that's to emphasize the fact that you really don't need to know so much. Many clinicians and many researchers themselves don't know so much about detailed statistics. So everyone needs a statistician. So we cannot emphasize that enough. There are so many other inferential statistics, but the commonest ones are the test of relationship and association, and then regression analysis. So most of the research work that we all do, these are the things that we need. Now, having analyzed your data, the next thing is that you now want to interpret the data and report. And it's important to emphasize that the way analyzed data is interpreted and presented really will determine how much readers understand your research work and what kind of impact your research work is likely to make. Poor interpretation of data really will mar even if you may do a very good, excellent research work, but if you don't interpret your data properly and you don't present it in a way that people can understand, then you really lose that high quality of the data that you have. So just a few tips about making sure that we interpret and present our data properly. This will usually be in the results section. And you know, what you want to do is to tell a good and compelling story of your work, to convince people that this work that you've done is important, that this work you've done is useful, and that this work that you have done can change practice or change whatever you are trying to change. But at the same time, don't try to scare people with numbers. A major mistake people make sometimes is that they put so much statistics and numbers into their data presentation that it just discourages people. And most reviewers, when they review a manuscript for publication and they see too much statistics, what comes to the reviewer's mind is this researcher trying to hide something by putting too much statistics there? So don't draw question marks to your work. So don't scare people with numbers. Don't overplay or exaggerate your data. And that is why, you know, there are times that people just, maybe they have 10 patients, and then out of 10 is even plenty. Maybe they have 5 patients, and then out of the 5, maybe the outcome was good in 3. And then they tell you, oh, outcome was good in more than 50%. But 50% of 5 doesn't make any sense. And that is why, if we always emphasize that when you present percentages, you should present the absolute numbers along with it, so that it gives the reader an idea about how strong the conclusion you are making is. And a rule of thumb is the fact that when you have numbers less than 25, you should avoid using percentages. You should just say exactly, if it's 10 out of 25, it's better to say 10 out of 25, because putting percentage may be misleading. Percentage are more useful when you are dealing with numbers that are more than 25. Also, if you have numbers that are, the sample you are dealing with is less than 100, then you should not be using decimal points in your percentage, because again, you should round up. That may be misleading if you put decimal points. We only start putting decimal points when the sample is more than 100. So these are little things that really improve the scientific quality of your work. And having said that, even though we say you should not exaggerate your data, but at the same time, you should not downplay your data, isn't it? Because you've spent so much time and money to do the work. The main thing is to be modest. And most importantly, use appropriate visuals and illustrations. Where necessary, use tables, charts, graphs. You know, they used to say that pictures speak louder than words. Putting the right illustration at a glance, just people can easily understand what you are trying to convey. People, you know, the average individual doesn't want to just continue to read text and text and text. It's not a storybook. So the more illustrations and visuals you have in your results and interpretation, it improves the scientific quality of your work. So I'll just highlight a few visuals and when we should use them. For tables, the main thing about tables is that we use them to summarize large amount of data and also to demonstrate comparison between, for instance, you have male and female. And as a rule of thumb, if you cannot present any data in 1 or 2 short sentences, then you need a table. So if you are going to write more than 2 sentences in order to present any data, then what it's saying is that you need a table to summarize that data. And once you put a table, all you need to do is just 1 or 2 lines to indicate what that table is saying. So how do we summarize descriptive statistics? Remember that we said descriptive statistics, they're about measures of central tendency and then measures of spread. So you can use a distribution plot, the kind of thing that we have that will help us to decide whether our sample is normally distributed or skewed. So you can actually make a plot of that. If the kind of study you've done, if normal or skewed distribution is something that is important, then you should put a distribution plot in your descriptive statistics. You can use a dispersion plot. This gives you an idea how the kind of spread you have. Example, for instance, if you have let's say age of the patients, and once you've put a dispersion plot, it gives you an idea where most of the patients are clustering, at which age, around which age are they clustering. If they are evenly distributed, then you know that, oh, okay, it means the patients are widely spread. But again, remember, descriptive statistics are just descriptive. They don't tell you any story. All they are telling you is that, oh, okay, this is the kind of data I have. This is the population that I studied. So don't read too much meaning into descriptive statistics. You may decide to use box plot. Again, that will help you to, the thing with box plot is that the upper limit of the box is 75% of the population. The lower limit is 25%. So that's your interquartile range. And then the line you see in the middle there is the median. So by having a box plot, it quickly tells you, gives you an idea what the interquartile range is. So, and we said interquartile range will give you a measure, it's a measure of the spread. And it tells you quickly what the median is likely to be, which is a measure of central tendency. So that's what the box plot does for you. You can use a pie chart. The thing with pie chart is that it just tells you what proportions are represented within that sample. They are really of very limited value because they really don't tell you so much, isn't it, beyond telling you, oh, so and so percent are located within this sample. So for really good research, many times we prefer not to use pie chart to illustrate things. If you are trying to compare categories, then you need to use a bar chart. Remember, if you have category, so an example you have here is prevalence of cleft lip in different age groups. So you have the different age groups and the prevalence. So the age groups are categories, isn't it? They are not completely continuous as such. So you can use a bar chart to illustrate that. The good thing about the bar chart is that, unlike the pie chart, it can tell you the absolute values of the different groups that you are talking about. Or if you have discrete or continuous variables, discrete variables means that there cannot be fractions. For instance, if you are talking about number of children, you are talking about parity, you cannot have fraction within them. So those are discrete variables. Or if there are continuous variables like height, weight, then you can use a histogram to really summarize those kind of variables. So remember, unlike bar charts that you are dealing with categorical variables, in a histogram, we are dealing with discrete or continuous variables. An error that many researchers make sometimes is sometimes they feel that you can interchange histograms and bar charts. No, you cannot do that because they summarize different types of variables and data. What about line chart? Line charts are useful when you are trying to demonstrate a trend. For instance, maybe you wanted to look at the annual frequency of cleft lip and palate in a given population. So you are looking at over the years, how is the frequency changing? So when you are looking at a trend change over time, then what you need is a line chart, because at a glance, it tells you immediately whether that change is, whether the frequency is increasing or reducing or has remained static. So it's important when you are trying to demonstrate a trend. There is the scatter plot. We use scatter plot when we are trying to compare two or more numerical variables. Remember, they have to be numerical, so they have to have numbers. So it should not be something that is categorical. And once because there are two variables, so assuming, let's say, for instance, you are looking at height and weight. And once you finish the scatter plot and you draw the best fit line through it, that should give you an idea about what kind of relationship exists between height and weight. Because if everything is clustering around one point, then you know that, oh, okay, so majority of the population, this weight and height are the really what are related with each other. But again, remember that you cannot just put a chart there. You must interpret what it's saying. You must summarize exactly what it is saying. A common mistake is that people sometimes researchers just put in the chart and say figure 1, scatter plot of height and weight. And that's all. That's not enough. You must say exactly what that scatter plot is saying. Sometimes people will say, oh, the scatter plot shows that age and height are related, and they end it there. No, so you must put in bracket figure so and so that the reader can go and look for that figure and see if exactly what you are saying is correct. So there are so many other different kinds of charts. The good thing with all the statistics softwares, even a simple Excel spreadsheet, we tell you, once you click on chart type, as you point your cursor to each chart type, it will tell you exactly when you should use it, so that you don't use the wrong chart. So I think that even if we are not statisticians, that will help us. So once you have your data, even on an Excel spreadsheet, and you want to create a chart, you just go to the chart type, put your cursor there, and it brings out the list of the different types of charts. And you see a very long list: funnel, plot, maps, different types. Once you point your cursor to them, it will tell you what kind of situation you can use them. So you can actually try to, if you have data, you can play around with charts, and with time you get used to them. So for simple data, you can do all that yourselves. But for a large data and for complex data, you probably will need a statistician to do that for you. So I think to summarize is to say that we should take advantage of good statistics to tell a good and compelling story of our research work. Once you are a researcher, statistics means everything. Sometimes you may have a very badly done research, provided once you have data, you can actually use statistics to make the results look good. But the important thing is that you must use the appropriate statistics and appropriate charts to interpret and present your data. Right, so I think I will pause there and then take questions and comments. So are there questions? I hope you were all hearing me.
Yes, we are hearing you. Questions
Okay.
and questions or clarifications. I think Amale has something on the chat.
Let me see. Right. So his question is, what of Excel as an electronic means of data collection? Yes, so you can use Excel. And the good thing, as I indicated during the talk, the good thing with the Excel spreadsheet is that you can import it. Sorry, you can export it into any type of statistical software. However, before you export, you must clean up the data to avoid mistakes. So that's if you are assuming you are collecting your data and you really don't have a purpose-made electronic platform to use, you can use Excel spreadsheet, but then you need to design it in a way that you won't forget. You know, sometimes we code data, and then sometimes you may finish coding, and when it comes to decoding, you forget what exactly you coded. So again, if you are going to be using Excel spreadsheet, make sure that you work on it with a statistician. You create the spreadsheet with the statistician so that as you are entering the data points, you don't make mistakes.
Thank you, sir.
Thank you. More comments and questions? Dr. Abdurazak.
Sir, good evening, sir.
Yes, good evening.
Yeah, so my question is, while it's important to engage a statistician in our researches, I want to know specifically do ones engage the statistician right from the beginning of the research or at a particular point, or just when one is ready for statistical analysis before one engages the statistician?
Ideally, and the usual advice is to engage the statistician from the beginning, from the time of study design. Why that is important is because the type of the way you are going to collect data, the way you are going to create your data collection platform depends on the type of study design you have chosen. The sample size that you are going to be using will depend on the study design. So it's good to have the statistician involved right from the beginning.
Okay, thank you.
Right. Dr. Abori Shade.
Good evening, sir. Thanks for the lecture, sir. So I have two questions, and even though one of them is a bit beyond the basic statistics that we talked today, but it's something that we cause whenever I have issues with sample size and some statistical tests. One, the size itself. What exactly does it mean that our sample size is small or is huge? I know that when we talk about central limit theorem, you always say 30. That once your sample is 30, then you can afford to breach some rules of normality, especially. I don't know whether from experience is when your sample size is over 30, is it really good to breach the rules of normality? Or even if it's over 30, you should just still try and test for normality before using either t-test or appropriate ones. That was one. Second is that I know that usually when you do chi-square test, some people have advocated for Kramer's test, the effect size. I really don't get to see it in most journals, most articles I read. People don't really talk about effect size following chi-square, whether it's significant or not. So I'm thinking, is it highfalutin to include effect size when after doing a chi-square test or after doing an infectious statistics for categorical bivariate, or is it still valid or is still important to still mention the effect size, either Kramer's or Phi, whatever one, even after doing a significant chi-square test? Thank you very much, sir.
Right, thank you. First about normality and the sample size. So two things. One of the things first that needs to be considered when we talk about sample size is the situation that you are studying. Remember that if you are studying a very rare situation or a situation that is not common, a small sample size for that particular study may actually be large because it's not something that is common. So I think the important thing is that once the sample size is small, and when we say small, it means you are dealing with usually it's not about the absolute numbers, but as you mentioned, once your sample size, in fact, once you talk, your sample size is less than 30, that is really small, isn't it? Even if it is more than 30, there is no way that sample will be normally distributed. So if you want to, there are some test statistics that are only applicable to a normally distributed data. So which means that when the statistician is going to analyze that data, he has to use a statistical tests that are applicable to skewed data. There are things that you can do to a skewed data to make it normally distributed. And that's where all those corrections factors that I was talking about come in. But statisticians will work on all that. I think as researchers, we shouldn't be too focused on that. The important thing is that to know that some statistical tests are only applicable to normally distributed data. Coming to effect size, why you don't see it mentioned in journals many times is the fact that really they are only useful when you are interpreting, you as the researcher, you are interpreting your data because you are trying to see what is the magnitude, even when you say something is statistically significant, really, what is the magnitude? Yes, it is statistically significant, but how important is that statistic significant? So that's where effect size comes in. So that's within, is for you as the researcher. You really don't need to put it into the manuscript itself, and that is why you don't really see it. Because if it's very large data, or a complex data, before a statistician makes a tells you categorically that this is statistically significant, he would have done all that about effect size. So, and journals don't want to go into too much complexity. So unless the data, what they are seeing contains so much statistics, then they will now ask a statistician to look at it. Then the statistician we now come back to you as the researcher and say, look, we need to know the effect size. But I think the main aim of the effect size is to determine the magnitude or impact of whatever association you are talking about. I hope I answered your comments. Any more questions?
Thank you very much, sir.
Yeah, right.
Good evening, Prof. Thank you for your presentation.
Yes, good evening. Yes.
My question, I hope it will apply to this topic. Usually when you, after receiving a grant from the sponsors, they usually tell you that before you go ahead to publish your data or your findings, you are supposed to share the data obtained with the funders, as in the sponsors, who will give you permission to go ahead to publish. I want to know, is it the raw data obtained that you submit to the funders, or the one that has been analyzed by the statistician that you sent to the funders? Thank you.
Right, thank you very much. I think that's a very important question. So, you know, what you submit to the funder is a report.
Yes, sir.
So because the raw data belongs to you as a researcher, they funded it, yes, and that is why you owe them a report. So the report is what you are going to put in the report is all that you did and the analyzed data, not the raw data. Because if you give them the raw data, you are then giving away your research work. So it's the raw data, and the analyzed data means that, remember, you may have had hypotheses or research questions. So you're only focusing on those aspects that, because what they want to know, has this research been useful or not? So that's one aspect. The other aspect is that as the researcher, you own the research. Yes, they funded it, but it is not for them to permit you to publish or not to publish. So their own is that they give you money, you've done the work, and you've given them a report. So they cannot decide for you whether to publish or not. They may tell you that if you are publishing, you should publish in an open access journal. Fine and good, because they are going to give you money for that open access publication. Or they may tell you that you must share the results of your study freely. And that freely means that once it has been published, you should share the publication freely. That they can do, but they will not tell you to publish or not to publish.
Thank you, Prof.
Thank you. Any more comments or questions? Right, so if there are no questions, are there any updates regarding all the research I know some people were supposed to submit corrected versions, and I know, has anybody already started their research work from SMITRAIN?
So we have not received any feedback.
Oh, okay.
I think the feedback is for those who are to resubmit. But yes. I think people have started their researches now, and they are in the house now. Dr. Patience and Dr. Bade. So they can
we have started our own. We are in the first arm of our study is a cross-sectional assessment of the utilization of the SMITRAIN mobile speech app, and the notice have been sent on different platforms, and we are getting responses from cleft care practitioners. And this first phase of the study is supposed to last for 1 month, after which we will analyze the data obtained and publish the results of the data obtained, after which we will now go into the second phase of the study. But for now, we are still within the first phase of the study, which is an online survey of the perception of the assessment of the awareness and the utilization of this app by cleft care professionals. And I want to seize this opportunity also to encourage all cleft care practitioners on this platform to go online and fill this online survey for us. Thank you very much, Prof.
Great, excellent. Patience?
Yes, sir. Good evening, Prof. Good evening, everybody. Yes, we've also started our research. We started this week. is the cross-sectional research on feeding nutrition in children with clefts, assessing their feeding practices and factors affecting feeding. So we've started data collection, and that's where we are. It will take about 6 months or hopefully less. So
Okay.
it's just started and it's starting well.
Oh, great. That's excellent. So for those who have submitted corrections, so any feedback from SmileTrain?
None so far, sir, at least from my hand. I've not received any.
Okay.
No
Okay.
feedback yet, sir.
Okay. I'm sure maybe.
We're all waiting.
Okay. Yeah, I'm sure soon they'll probably do that, because I think they want to quickly conclude this first round so that they can advertise for another round.
Okay, sir.
Yes. So I think we should remain hopeful.
All right.
Okay. All right. So any more comments?
No, just to thank you for what you have done. And I think it's a very good thing for this platform. And hopefully we are hopeful that the outstanding proposals will be accepted and the work will start. And I think from the experience of the two that have started, I think using GSI as their, to host their grants, I think it makes life much easier for them to access that. So for others, I think you can interact with these two people to see and to advise you, and also about the use of statistician. I think Dr. Bade also has an experience that can share with the house so that people will know, depending on the type of research you are doing. So I want to thank Professor Ahmed for this mentorship, and I hope that all of us will benefit adequately and can also take it to the highest heights. Thank you very much.
Thank you. So thank you very much, everyone. Have a good night and a good weekend. Okay,
Thank you, sir.
Okay, thank you, sir. Thank you.
Good night. Thank you, sir.
Good night.
All right. Ordered the video to address this tomorrow. Thank you. Good night.